This video instruction covers the procedure for high-level intrusive inspection and defect rectification of overhead line electrification and applies to all designs of OLE. When planning a high-level intrusive inspection, data for the necessary height and stagger adjustments will have been obtained from a manual height and stagger survey, or from train-borne height and stagger data. During the inspection, plan to remove critical defects and complete campaign changes, and if necessary, request additional access time. The important thing is to leave the wire run asset in improved condition so that it will deliver reliable performance until the next high-level inspection. This can only be done if we positively address the known defects. Tapping droppers to realign them will not achieve our CP5 objectives. On the day of the inspection, the person leading the inspection shall have the standard maintenance record sheet in the form of a standard single page and multi-page waifs. For example, EPF OLE 011, 011. This will be replaced in the near future by the Mobile Works app. A copy of existing defects from the work management system to rectify during the work. Specific technical investigation requirements and emerging issues. For example, the types of fittings that require physical checks. The team carrying out the inspection shall have with them a standard overhead line toolkit including a calibrated torque wrench, a pulley wheel grease gun, all necessary materials to effect repairs, a means of capturing digital images in case we need to record and escalate issues for technical advice. When completing a high-level intrusive inspection, these are the key tasks you should complete over the course of the inspection. Assess the correct OLE setup, separation and condition. Check all fittings and assemblies on the overhead line and establish they haven't moved and are fitted where required. Check fittings for security. Where adjustment is needed, when tightening, apply the correct torque settings as per work instruction NR OLE A02. Where components are found to be loose, carry out additional checks for burning or damage on the loose component and associated fittings. Inspect where short-circuit flashovers have occurred or where there are signs of a flashover that hasn't been reported. It also makes sense to check the bond connections at the same location. Also inspect all pins, pulleys, fittings, small part steelworks, SPS and conductors for damage. Then re-grease using approved grease where required. Record and remove all critical defects. Other defects should be recorded and rectified where reasonably practicable, and those remaining recorded and prioritized in accordance with the standard defect prioritization matrix. It is important that we record defects that are fixed so we can base our maintenance regimes on the correct information. Specific HLI tasks. These are some of the specific procedures you must complete to rectify issues when completing a high-level intrusive inspection. Terminations. Start by checking the security of fastenings and pins. Examine all termination wires and identify damage or stranding. Check for free movement of pulley wheels and balance weights by manually moving the weights from ground level. Grease the pulley wheel bearings via the grease nipples. Always use the approved grease. Check pulley wheel bearings for water penetration into the bearing housing and look for signs of seizing or bearing collapse within the wheel. Inspect the equalizing plate for correct alignment and adjust as required. Check for signs of fatigue and cracking on all double clevis 808 fittings. Check and record rotating A-frame and anchor structure movement. If the A-frame is rotated, check and realign the guide tubes as necessary. Insulators. Check all insulators, including those on cable sealing ends, for signs of damage from flashover, mechanical damage or build-up of dirt and pollution. Clean the insulators with approved cleaning products where necessary. Support and registration. Check the uplift movement of the registration arm. If there is any difficulty or the arm appears unduly slack, inspect the registration pin for wear. Check that the along track movement of the registration arm is correct for the ambient temperature. Compare the extent and freedom of along track movement with the adjacent registration arms. Registration arms should move in increasing amounts from the midpoint anchor to the balance weights or tensioning device. If it is not possible to do this without detaching the arm from the contact wire, then it should not be done unless there are indications that free movement is not taking place. For example, a bent arm or a heavily corroded pivot assembly. Also check the heel setting. Check for excessive wear and signs of electrical erosion around the hook and eye fitting. Check windstay dropper, nose dropper and V-dropper to confirm they are not slack and to identify any wear on the eye. Check for free movement of suspension and bridle pulley wheels. Check all Mark 1, Mark 1 UK1 MIR swivel bracket assemblies for the presence of at least 2 safety retaining E-clips. Fit new clips where required using the applicator tool. Check cantilever tube crimp integrity and for adequate strut tube drainage. This check should also be performed on inverted cantilevers. Check span wires for loss of tension, damage, caging, stranding, and for component slippage. Check bridle wires for damage, caging, and stranding. Overlaps and crossovers. At OLE overlaps and crossovers, start by checking the parallel running of the contact wires. Takeover from one wire to the other should be checked using a pantograph head for smooth takeover and parallel running. Note the minimum takeover for high-speed lines is 8 meters. Check all feeder cables and jumpers for secure connections and examine for stranding or caging. Check for contact wire side wear on converging and diverging wires. This aligns with campaign change number 78. Pantograph horns can rub on converging wires, and the metallic horn wears the copper contact wire very quickly, resulting in dewirement. Conductors. Conductors must be measured at locations of maximum wear so that the worst wire condition is recorded. That is where excessive contact wire wear and side wear is observed. For example, close to discrete features such as neutral sections, section insulators, or just after registration arms and knuckles. Start by measuring the depth of the wear using a micrometer or vernier caliper. Where measurements have been taken, confirm that each point is clearly marked with paint either side of the measured point on the top of the wire. Record the measured value, structure number, and track ID. Check contact wire and catenary wire for kinks, arcing damage and wear. Examine all other wires for corrosion, damage, caging, flattening, or stranding. Focus on reduced clearance locations such as overbridges and where wires go out to anchor passing near return conductors. Examine installed splices for signs of cracking or fatigue. On Mark 1 and UK1 equipment, inspect the copper catenary on pulley wheels and suspension clamps, including the hidden area within the pulley wheel and clamp. A catenary splice shall be installed where parted strands or flattening is evident. In-span assemblies. When inspecting in-span assemblies, start by tapping each fitting. Check the security of each fixing to the conductor. Apply the correct torque when retightening any fittings. Check droppers for excessive misalignment and ensure that the dropper clip is securely in the contact wire groove. Check copper drops for distortion, wear, caging, and strand damage. Replace any damaged droppers and record the defect. Check bent stainless steel droppers for any signs of fatigue cracking. Check copper loop droppers for wear in the loops. Check catenary protectors, aeroplanes and saddles are fitted to the catenary and correctly aligned. Inspect for signs of wear or damage to the catenary due to dropper movement, and replace or repair as necessary. Check for deformity or corrosion of bimetallic fittings. Pay particular attention to the seal around the friction weld interface. Cross contact bar. Check the cross contact bars for the security of fittings, correct number of parallel groove clamps, and wear or distortion of the rod or contact bridge. The wire should be lightly bearing on the cross contact bridge. If necessary, adjust the contact wire geometry as required and renew the rod or contact bridge. On tangent track, an approximate check of correct geometry can be made using a straight edge and spirit level. Both contact wires should be level at the 500 mm separation point. A vehicle equipped with a pantograph head should be used to confirm correct running following adjustment. Track feeders. Along track feeders, including auto transformer feeders, return conductors and aerial earths. Look at the sag of the conductor and identify damage or stranding. Check for damage and burning at the booster transformer connection. Check adequacy of electrical and mechanical clearances. Pay particular attention to overbridges and overlaps. Where uninsulated conductors cross over live OLE, a minimum 600 mm clearance under all temperature conditions is required. Check that insulation and shrouding is intact, secure and undamaged. Check that along track conductor splices have not been overcrimped or deformed. Make a note of locations where a long track conductor or aerial earths cross over open routes. Overbridges and tunnels. Overbridges and tunnels must be inspected with extreme care. There may be special reduced clearances where steelwork is painted white. It will be necessary to check condition of steelwork and the white paint. Check the mechanical and electrical clearances from overbridge structures to all live parts of the OLE. Record worst case clearance value for all bridges. This is a recent change to the work instruction. Record the worst case clearance values for each wire run under inspection. Check condition of earthing strips for detached fastening and damage and security. Report if the earth strip is missing. Check electrical connection of traction return bonding from the earthing strip to rail. Check electrical connections to earth wire at clamp supports for corrosion and for arc damage, especially if they are installed in wet or polluted environments. Where bridge supports are fitted, check them for free movement. Inspect all insulators for flashover damage, mechanical damage or build-up of dirt and pollution. Clean where necessary. Check for evidence of arcing at the bridge arm and for arc erosion along the arm. Check alignment of block droppers. Where there is evidence of tracking or short circuit to the registration, take off the contact wire clip and inspect for damage. Inspect bolts attached to the bridge or tunnel to ascertain they are spanner tight. Vibrate by hand to assess the security of the bolts. Check at overbridges, where solid stainless steel loop droppers are fitted, that there is no wear on the suspending catenary. Rectify defects and install stainless steel saddle. Check for water ingress that is affecting electrical clearances. When found, rectify the area and record the location. Vegetation and fauna. Vegetation encroaching the overhead line equipment shall be removed depending on proximity. Buddleia and other vegetation growing on structures encroaching the overhead line equipment should be trimmed back as required. Do not pull from the structure, but cut to trim back. Birds' nests on or near the overhead line shall be removed, but note that permission may be required. BICC ceramic bead neutral sections. In BICC ceramic bead neutral sections, inspect the complete neutral section assembly and associated OLE for damage, burning, evidence of poor running, and for signs of excessive wear. Inspect the ceramic bead units and check if the beads, cement, or PTFE spacers are missing, chipped, cracked, or have been previously repaired. Inspect the unit for any evidence of cement erosion between the ceramic beads, which would allow ingress from pollution. If undamaged, clean the insulators using approved cleaning products. Refer to NR, OLE, C12 if required. Examine the earth jumper at the midpoint of the neutral section to check for burning, fraying, or other damage. Examine the catenary end fittings for damage and wear. Verify the positioning and security of the arcing horns. Check the telescopic anti-torsion droppers are vertical and that the inner tube moves freely up and down the inside of the outer tube. The length of the spring should be 170 mm with an available uplift of 75 mm. If this uplift cannot be achieved, adjust or replace the arrangement. Check that the PTFE sleeve is not worn or displaced. To do this, remove the neoprene bellows or spring dropper at the bottom of the dropper. Also, check that the seal at the top of the tube is in place, and examine the clamps on the anti-torsion tube between the main and auxiliary catenary where fitted, and tighten if slack. Correct any twist observed. Replace any worn or defective parts. Check neoprene bellow arrangements. Check and clean the bellows. Check the tube clamps and confirm all split pins are in place, fitted correctly and in good condition. Arthur Flurry neutral sections. In Arthur Flurry neutral sections, inspect the complete neutral section assembly and associated OLE for damage, burning, evidence of poor running, and for signs of excessive wear. Check PTFE rods for excessive wear. Check the security and positioning of lever arm attachment where the lever arm is fitted. Check for free movement on the spring droppers. 160 mm of uplift is required. Check for excessive gapping between the PTFE rod and the stainless steel end ferrule. Report if this gap is greater than 10 mm. Check the arcing horns are intact and free from arcing damage. Check the integrity of the arcing horn at the weld interfaces and for signs of cracking. Replace as required. Check feeder wires for stranding and for any damage to the isolating switches. Check the condition of the earth jumper and the connections to the rod assembly and structure. Check the wear patterns at the interface between the contact wire and ferrule. Record the number of turns on the PTFE rod. If skids fitted, check for security, damage or uneven wear. Arthur Flurry section insulators. In Arthur Flurry section insulators, inspect the complete assembly and associated OLE for damage, burning, evidence of poor running, and for signs of excessive wear. Check for excessive wear on the section insulator skids. Pay particular attention to fatigue cracks and closely inspect the ends of the skids as they incur extra wear. If uneven wear is present, minor adjustment can be made to the V-dropper to compensate for track cant and pantograph uplift. Check for excessive wear and burning on the PTFE rods. Check the security of bolts on the reinforcing bar assembly. Check that the hanger assembly is under tension. All turnbuckles should have locking wires fitted and hanger tails should be secure. Bonding. Secure and torque connections at the terminations. Check the insulation sheathing. Check for decolorization. Check for damage and detachment. Check for burning.